All right. We've got some rules here. One, again, angle bisector, bisector, bisector. That means this is a triangle bisector, which means this is the same as this. I can do that. That's all it means. Right? So it is also the same as this. So x, right, is equal to 4x plus 10. Right? Almost. Almost, right? We're going to have two of these. Okay? This is probably going to come up funky, probably negative, but that's okay. X can be negative, right? The sides might come up negative. That would be bad, but you're just doing the math that's in front of you. So just remember that. We can also later go, oh, that's impossible, you know. So I've got...
Isn't that minus 10? 4x minus 10?
Oh, does it say minus 10?
Yeah.
I would like it to be. That would make it a lot better. So good. Let me just read that. Thank goodness. Alright, so I'm going to subtract the 2x from this side and from this side, right? So I get 0 is equal to 2x minus 10. And so here, remember I have, why can we do this? Definition of the triangle bisector. Okay, next, subtraction property of equality. Next, plus 10 plus 10, so 10 equals 2x. Okay, addition property of equality. Divide by 2, 5 equals x. Okay, division property of equality. Okay, plug it in, and you get 4 times 5 minus 10, so I get 20 minus 10, and I get 10. So this side is 10. That means this side is 10. Okay? And again, substitution. Okay, and simplification. Now, I want to do the same thing. So we know that this is the same as this. Right? Oh, whoa. Hold your roll. My bad. This isn't, no. This piece, right? This is this for the whole bottom, or is that just for that one side?
That side.
That side. So is this x equal to this? Yeah. So this would not happen in this case. If this were the whole thing, then we need 2 of these, right? But the way it's set up is that this is equal to this, right? So this is all going to change just a little bit.
The 4x minus 10 is on the other side.
Well, you can set it up on the other side. It can go either way.
Oh, okay.
But the whole key here is that we don't have 2x, right? We don't need 2 of these because it's not the whole piece. This is only describing that one half. So that when I set it up, I was like, yeah, that's right. And then I double guessed myself. Right? So be careful when you're setting these up. Know what this is set for. If it's just this half, then it is equal to this. So I can subtract x, and it makes it for a little funkier problem, right? I kind of like it the other way, but either way, In this case, I got 0 is equal to 3x minus 10. Still going to have the same properties, right? Add 10. So we get 10 is equal to 3x. And then I'm going to divide by 3. Everything's really the same, except I come up with 3 1/3 instead of with 10, right? And then when I plug that back in, I've got 4 times 3 1/3, which is 12 4/3, which is 13 1/3, minus 10, so I'm back to 3 1/3. So I know that this side is 3 1/3. Okay? Then we come back to here, and where I saw this was, I see that 21 was equal to 3z, right? Plus 5. So now I do all my stuff again. Minus 5, and I got 16 is equal to 3z. Divide by 3, and I get 5 1/3 is equal to z. Plug it back in, and I get 3 times 5 1/3, which means it's really 16 over 3, right? Plus 5, so I got 16 plus 5, which is 21. So this has to be 21. This has to be 3 1/3. And this last one, I'm maybe missing some information here. 3z, no, x, 3y, 2y plus 4. Okay, so again, 3y minus 2 is equal to 2y plus 4. So subtract 2y, I get y minus 2 is equal to 4 plus 2, y is equal to 6. Okay? And when I plug it back in, I have 2 times 6 plus 4, and that's 12 plus 4, which is 16. So this is 16. Right? Okay, we're done on that. That was a lot of them. Okay. Oh, and that was problem 25, right?